In the evolving data landscape of 2026, organizations face a profound paradigm shift. The browser-side pixel, once heralded as the definitive metric for online behavioral data, has been relegated to a supporting role. This transition is catalyzed by widespread adoption of ad blockers, increasingly aggressive browser tracking prevention mechanisms, such as intelligent tracking prevention, IDP, and the definitive demise of third-party cookies. The implication is unmistakable. Exclusive reliance on browser-based tracking jeopardizes the accuracy of measurement frameworks, ultimately undermining digital marketing efficacy. The emergence and adoption of the Conversions API, CAPI, offers an innovative countermeasure. Unlike conventional pixel tracking, which transmits event data from the client browser to ad platforms, CAPI establishes a robust server-to-server conduit. This server-side paradigm is not merely a technological pivot, but a strategic evolution forged to address the persistent issue of signal loss. Signal loss, a phenomenon wherein browser constraints hinder the transmission of critical post-conversion data to ad platforms, erodes reported return on ad spend, ROAS, and impairs the data-driven algorithms central to campaign optimization. CAPI circumvents this bottleneck. By routing signals directly from an organization's server to the ad platform, CAPI ensures consistent and comprehensive measurement, even in the face of client-side privacy interventions. The event data, now liberated from the browser's volatile environment, is less vulnerable to user-initiated and software-enforced interruptions. In practical terms, this keeps machine learning models well-nourished with reliable data, sustaining both efficiency and relevance. A distinction must be drawn between traditional browser pixels and modern server-side APIs. While pixels historically excelled at capturing high-funnel behavioral nuances, such as dwell times, scroll depths, and micro-interactions, server-side APIs have become indispensable for validating lower-funnel events, including purchases, sign-ups, and generated leads. Events sourced from a server inherit a higher degree of security and reliability. They are insulated from page latency, script execution errors, and the myriad uncertainties of heterogeneous client environments. The effectiveness of CAPI hinges upon a critical metric known as event match quality, EMQ. Success is measured by how accurately a tracked event can be reconciled with a distinct user on the platform. To bolster EMQ, practitioners routinely employ data redundancy, dispatching both pixel and CAPI events with a shared, unique event_ID. This redundancy enables ad platforms to deduplicate signals, thereby safeguarding against both data inflation from double counting and data scarcity from loss. Furthermore, by augmenting event payloads with hashed user identifiers, such as email addresses, phone numbers, or IP addresses, the fidelity of server-generated event improves, directly enhancing attribution and downstream measurement accuracy. Implementation of CAPI, however, is accompanied by non-trivial technical demands. Integrators must deploy either a server-side tag manager, such as Google Tag Manager server-side, or develop bespoke API connections. Paramount among the engineering challenges is minimizing data latency, ensuring that server-originating events are transmitted with sufficient rapidity to support real-time bidding and responsive algorithmic adaptations. Moreover, the shift to server-side data control elevates privacy obligations. Organizations bear direct responsibility for ensuring their data pipelines are compliant with regional and international standards, such as GDPR and CCPA, mandating hashed, secure transmission of first-party identifiers and transparent governance over data lifecycle management. Ultimately, the adoption of CAPI is more than a reactionary measure to the sunsetting of third-party cookies. It signals the construction of a proprietary data infrastructure, a privacy-first digital architecture in which first-party data becomes the linchpin of competitive advantage. In a world where external identifiers grow sparse and opaque, those with mature server-to-server integrations will enjoy superior resilience and adaptability. Future-proofing the measurement stack, therefore, is not solely about surviving the transition, but about thriving in a marketplace defined by privacy, precision, and technological rigor.